Greetings. Is the sound working? Yeah, appears to be. Welcome to another stream. Kind of want to do these every day, but sometimes I don't really know what I'm going to do. And this is no different. I've only a vague plan, which often means whoa. Which often means I end up. That seems broken. Oh, it's back. Which often means I end up thinking a lot on stream, which is always the most engaging viewing. Last time we made a little entity, placed it somewhere, gave it a model, kind of, and, well, it gave it the opportunity to assign a model to itself, but none of that code's hooked up to anything, so it doesn't show up and nothing happens. Today I want to start hacking the rendering, see if we can get a model to appear. I think it's just a picnic table. Unfortunately there's a lot of bits and pieces in the rendering, so I don't think I'll get much done today. But maybe, if I'm very productive, it's not impossible. We can get to the situation where we can see a picnic table. But don't count on it. And as always, I'm taking song requests. So if you have a song request, I don't think anyone watches the start of the stream, so I don't think anyone knows I'm doing that. But one day I'll get a request, and I won't know it because I don't know any songs. So what did I implement? Oh, here we go. Yeah, this is why it doesn't show anything. So it calls through to load asset, or maybe it doesn't. I can't remember if I hooked it up. And then it just doesn't do anything. But that's fine, because there's nowhere for that to really go. And let's change that. So what I want to do is take the geometry for all the rooms, all the 8 faces of the tesseract, which you can see here. There's this blue one, 1, 2, 3, 4, 5, 6. Plus the blue one is 7, and the red one is 8. It's actually watermelons. All of that geometry, and all the geometry for any other meshes that are loaded up. That are static meshes. They don't have bones or anything. They're just vertices and textures and stuff. And I'm going to splat it all into a big buffer. Well, all the vertices into a big buffer. And then think about textures later. Because I kind of know what to do. But one problem at a time. Okay, so I want to put all of the stuff into a big bucket. So I'm going to make a class called bucket. Is it going to be a class? Probably. Feels like I'm going to make it a class. Yeah, I'll just do it. Here, it's a class called bucket. Haha. I'm going to include my OpenGL headers. And what are we going to do with them? I'm going to go into render room. It's got a couple buffers. That's exactly the buffers that we want here. Private field is not used. Yeah, I don't care. These are named really badly. It's array buffer, element array buffer, and vertices and indices. I'm just going to call it vertex buffer and index buffer because that's more logical. That's kind of how I think of them, rather than array buffer and element array buffer, which is not the most awesome naming scheme under the sun. Oh, I'm gonna make a little struct bucket state. So I'm gonna have lots and lots of little I'm going to have a big vertex buffer with the vertices for a bunch of different models, and then the index buffer with the indexes into those vertices. I'm going to incorrectly pluralize vertex and index a bunch of times here. Deal with it. So I probably want to remember, I'm just going to use ints because that's completely lazy and I'll change it later. I probably need to remember to draw triangles. I need to remember the start and the count in of the indexes and the offset of vertices. So for the first model, the start's going to be 0 and the offset's going to be 0 and the count is just going to be how many indices there are. And for the second model, if I draw this out, so okay, that's an extremely wide canvas. So you're going to have a vertex buffer, it's going to have some vertexes for a piece of geometry 1, vertices for a piece of geometry 2, and so on. And there's also going to be indices. It's not going to be the same length. Maybe it's a bit... Well, it'll probably be a lot smaller because indices are just 16-bit, whereas vertices are probably a bunch more, like 32 or 40 bits or whatever. So it's indices for model 1, which is going to refer to this stuff. And then indices for model 2, which is going to refer to this stuff. But these are all going to be indexing from 0. So what this considers 0 needs to be offset by this much. I also need to know this offset and this size. That's all the info you need to render it, I think. That, if I'm wrong, then that's too bad. Okay, cool. I'll make some private functions straight up. Alright, prepare buffers function. Alright, I'm gonna use site. I just use integer. Okay, I need to now make a CPP file so I can write that function. Wow! I like programming. It's fun. Well, can be. The results are often a lot of fun. Actually, the results are often just nonsense. Okay, let's make that little function. I want the function to prepare the buffers. This is going to be mostly poaching from render room. So render room does this. So allocate, well, if what I need to do, I just want to go here. I want to check how do these buffers work. It's a managed ID for a managed buffer implements allocate and dispose. So it's a managed ID, which is just a little template which has an ID. Initializes it to 0, yes it does. And when it goes out of scope, it calls dispose. The allocate function will reallocate it if necessary. And the dispose function will dispose it and clean up the ID. And it casts itself straight to a GL uint. So it's just a little thing that tidies up after itself. It's like a extremely basic smart porter almost type thing. I just want to check that saying if not index buffer, is that going to make sense? And it seems like it is. The static draw, well, that's not necessarily true, but let's just leave it like that. So there's no data. But oh, someone messaged me. Ha! Joke's on them. So we're gonna make it the right size. Okay, there we go. We can now prepare a buffer. I say that. We also want to fill the buffer. Might need to do this separately for each buffer. Let's concentrate on the vertex buffer for now. Okay, let's just I'm not totally sure what parameters it's going to take, so let's start off with an empty function. Let's look at render room, because that actually does do some buffer filling. It does it like this. So it's the size in bytes times this number of vertices, so that's just like the actual size. Data. Let's just check what jail buffer data actually takes as a pointer. It takes void star, so we want the byte size. We don't want to fill it from the start. Is it sub buffer sub data or something? Yeah, buffer sub data will let you fill up a portion of a buffer. So presumably we can. All right, you know what? Let me just put the name bytes here. That is barely better than like it's like putting a warning on a gun saying, "Hey, don't shoot yourself," but. It's better than not having it sloppy, but who cares? Buffer sub data will let you like fill in just part of a buffer. So if I just want to chuck this bit in like that, then the fart noise is the sound effect of it going in. Then that just takes something like this, offset bytes, that's definitely size bytes, and this is the data. Again, I'm just setting it to static draw. Vertex, I have truly transcended poor pluralization. This is not really vertices. I want to record the vertex buffer size in bytes. And the index buffer size in bytes. And I only really want to recreate these buffers from scratch if they're not big enough. This is going to be just a 100% start from scratch if you need to reallocate anything, which isn't a very it isn't a very happy way of doing stuff. But since this is all static geometry, I don't really care because it's not going to change very much. When the game level is running, the geometry is going to be static. I'm going to change these to size t because something else was size t, and it kind of makes sense for it to be positive. cool. So buffer subdata, bytes. I didn't do anything there, but here's where I was thinking. I do need to set the size here and here. Okay, this is sort of a thing. Oh, you know what, we could do some asserts. Assert, offset, bytes. Let's just make everything size t. These shouldn't be plus size bytes is less than or equal to m vertex buffer size bytes. Okay, cool. So we just put an assert in case we try and fill the buffer in the most wrong and unnatural way possible. And I guess I'll just copy paste the function for indices. That seems awfully rubbish, but it's a 3-line function. Oh, this does not take the buffer type. Yeah, there we go. It's happy now. Okay. Right, but I fooled you all. I'm not going to duplicate a 3-line function. That would be silly. Never duplicate code. Actually, it's a 3-line function. Duplicate code if you want. I fooled myself. I was going to pass in all the things, but it's like this, and this, and this, and this. It's too much stuff. Element array buffer. This is for the indexes. And we're binding the index buffer, but other than that, it's exactly the same. Okay, let's try building this wonderful class. It's so wonderful that I will not even care if it builds. It built, I guess. Let's check the compile output. Yeah, it did. Hooray! I mean, that's not very interesting. That's just some rubbish private functions that I can't even access. So what I really want to do is take these meshes, which have a bunch of vertices and a bunch of indices, and just take a big old bunch of them and plop them into a bucket and get a bunch of bucket states back. Again, bucket states indicating how to render stuff from the bucket. From the big old buffer. Okay, so we want to take a bunch of meshes, but the meshes themselves are templates because you can have different vertices. But seeing as the whole bucket's just going to be filled in one function, if you want to do different vertices, that's on you. Highly not recommended. It's going to be fill. I'm going to get a vector, I guess, of mesh pointers. I probably need a bind function as well, just to bind these things. Right. Okay. Right. How do we go about filling these? Okay, let's just be super simple. First, we kind of need to know how many vertices and indices there are. My shift key does not work every time. It's 50% reliable. I can live with it. So I think this function needs a bunch of stuff. That's why I made them size T. Okay, so now we know how big the buffers should be. We can call prepared buffers on vertex count, but it's size in bytes, times size size of mesh vertex type, and index count times size of mesh index type. Cool, so we got the buffers ready from a big list of meshes. That was easy, and maybe it even works. It seems like it should work, probably. But now we need to fill each, to place each mesh into the buffer. I'm just thinking if I should do all of the indices and all of the vertices. That would probably be best, I would imagine. But it would mean looping through everything a bunch of times. So let's just make it simple. Okay. This needs to remember a bunch of bucket states. And when we fill the buffer, if it's already full, well, we're going to clear all those states out because we're going to overwrite everything. Okay, cool. We've prepared the buffers. Now, for each mesh, we want to make a bucket state so we know how to render that part of the bucket, and chuck the vertex info and the index info into the buffers. So we definitely need to loop through the meshes again. Okay, so we've got a mesh here. We're going to fill the vertex buffer. Offset size in bytes. Okay, well, whoops. No. Wait, we'll just reuse vertex count is now 0 again. Index count can also be 0 again. Okay, we want to fill the buffer. Well, how many vertices have we done? That many. 0. The size in bytes. That's this mesh. Vertices. Size times size of mesh. Vertex type. And finally, a pointer to the vertices. Well, that would be mesh vertices data. Well, that seems okay. We could probably do the index buffer in a pretty similar way with a bit of copy paste silliness. Okay. Once again it compiles, but these template functions don't get instantiated if you don't call them. So at the moment this, you know, mesh plus 7 equals 5. Yeah, cool, whatever. It doesn't, which could be a valid operation in C++ because you could overload operator plus to return some type that can be assigned to. So, you know, it's syntactically valid. Like if I do an actual syntax error here, yeah, it's not going to like that. So as long as it's syntactically valid, it doesn't actually, it's not checking any of this at this stage. I guess it is checking the function calls. Okay. So I also need to make a bucket state which is going to be, so what were the values here? It's going to be draw it up in red. The start is how many indices there are. Everything's good. Yeah, it's still working. Is that not used? I feel like that is used. Oh, because I've... Oh, sorry, it's giving me a bunch of errors. So, let's index count. The number of indices is mesh indices size. And the offset is vertex count. So I'll push that back. Cool. And then your vertex count is just going to increase by mesh vertices size, and the index count is going to increase by mesh indices size. Cool. So that should generate a bunch of these things. These things which can be used in the call to draw elements. No, actually that's not at all the one that can be used, because that only draws a full bucket. It's GL draw. Is it elements base vertex? Yeah. So this mode is going to be triangles, because triangles are what everyone draws. Count is the number to draw. Type, unsigned short or whatever it is. The actual indices pointed to the location where the indices are stored. That's definitely got a bunch of different meanings. It doesn't have examples here, but that it's one of these OpenGL things where it's a pointer because you can give it like a pointer to an array in C, or you can make the pointer an offset or whatever, and it kind of does different things. Honestly, it's bonkers, and I don't know why they keep... I don't know why they designed a bunch of stuff like that. But I'm pretty sure that's just the offset into the array. And the base vertex is to, yeah, do something. So that's cool. No, the base vertex is for this. If you have index set 2 here, and it's like talking about vertex 0, vertex 1, vertex 2. Obviously, if this is in a bigger bucket, this is actually probably be like vertex 4810, 4811, and so on. So you just give it the offset 4810 in this example. So then it knows these indices refers from this point onwards. So you draw the right thing. That's nice. So you can stick all your stuff in one big buffer. Okay. It's still unhappy. Bind. I should do a bind function. It's gonna be rubbish. Why did I put C assert? It's just assert. I'm getting mixed up with the name. of the header file. That was a really weird way of doing that. There we go. A rubbish bind function. It makes sure you've actually done the things to make this valid, and it binds these things in. Easy peasy. Okay, so now we've got a bucket. We can fill it up with stuff. What do we do now? Well, we're going to make another class. This one is going to be for just holding some static geometry. I want to call it static geometry because static is a keyword and geometry is extremely vague in a game entirely based around geometry. Everything is geometry. So it's going to be a model. Let's call it model. Well, let's just start with the header file and see if we go anywhere. Okay, let's make a class to store a model. Pragma once. Okay, so it gets multiply included. Okay, it's going to be a class because I'm somewhat boring. The functional stuff, well, in rendering, I feel more OOP with this stuff. Even though OpenGL is like a state machine, and a lot of the actual game code I've written so far is not very OOP. Sometimes things just feel object oriented, and sometimes they feel functional, and just trust your instincts. They're really two sides of the same coin, so, you know, don't tell anyone. Okay, There's no mesh. There is a mesh in render though. So it's going to have a mesh. Interesting. It needs, this vertex type needs to be generic. Let's also make another file called Draw Manager, which I've talked about like 4 times on stream. And the reason I haven't made it is because I still don't really know what it is, but it's the final stage of OOP when you really don't know what you're doing and using OOP as a crutch. You make a manager class because more layers of management is definitely what anyone needs. Let's go this dang vertex somewhere. Okay, here it is. This vertex needs to be in a header file, and I'm going to call it no, what? I'm going to actually give it a namespace. Instead of changing the name of vertex, because it truly is just a vertex, I'm going to put it in space, namespace for static geometry. How do I do my namespaces? Have I done any namespaces? I've done a lot of namespaces. I do them first caps like everything else. Okay. Really, this draw manager should have a bunch of things. So I'm pretty convinced already that this is an incorrect way of doing this. But I don't know what the correct way is. And at least doing something wrong is better than doing nothing. I may find out along the way what I should be doing, and then I can press the delete button. A lot of times, deleting a lot of code, and deleted code is the best kind of code because it doesn't have any bugs once it's been deleted. That's very true. I'm very tired. Let me have a drink of water. Okay, I feel refreshed. Programs? Some programs, it's like different render paths. I don't know, like pipelines. I don't really like the term pipeline. It feels a bit. What is the pipe conceptually? Well, I don't need an enum because I was going to do an enum for the different types of rendering, but then I just realized I only have one type right now. So I'll add an enum when I have at least two types. Yeah, I really don't know what to do here, but I do know that that static geometry vertex probably shouldn't even be there. But like I said, it's better to do something than to do nothing at all. I'm going to make a mesh of static geometry vertices. Cool. Right, so what's a mesh, what's a model going to be? I'm going to give it a dirty flag, which is going to be true because the mesh is not built on startup. Dirty flag should always start as dirty. Nothing should start clean. It's not clean until you've cleaned it. Which isn't actually what dirty flags measure. It's not up to date until you've inspected it. Okay, so cool. It's a model. Let's load a model. Here's a file name. Yeah, that's all I need. It could be an obj file. I never made a corresponding CPP file. Well, we can make one. There it is. It appeared. Okay, so I did take a look, I think just yesterday, at the obj file format, and it's pretty simple. In fact, it's a really nice format because it's so simple. You can learn it just by looking at one of the files, or you can kind of learn it. It doesn't know what a standard string is. Okay, back. There we go. So just to hammer that point home, let's open this file again and run through it. So it starts off with a big bunch of vertices. Well, first of all, O for different objects. I'm probably just going to combine them together because, I mean, they're separate things, but they could just be considered the same. And then V to determine a vertex with spatial coordinates. And after a bunch of them, there's VT to define different texture coordinates, and VN to define different normals. There's not the same number of V's, VT's, and VN's, there's just a bunch of them. And then S gets turned off, whatever that means. And then F just gives you a triplet of triplets, determining a vertex, texture coordinate, and normal for a bunch of different things. Triangle. It defines, that's the word I'm looking for. It defines a triangle. It's on the tip of my tongue. And then it defines another object, it defines more vertices, defines more texture coordinates, defines more normals. Wow, it defines a lot of them. Let's skip to the end. Texture coordinates, normals, and a bunch more triangles. And that's it. It's a very simple file format. What makes me confused, the one thing that makes me a little uncertain, is that some of these appear just once. Okay, a lot of them appear just once. Some of them appear more than once. What I don't want to do, well, I want to make sure that I'm not duplicating vertices. And there's some redundancy here. I mean, I guess I could just make a huge data structure recording each one that I make. But there's thousands. That would take up kilobytes of memory. So I'll probably just do that because kilobytes of memory is not very much. Right, we want to load this file. And this is going to be a bunch of hacks. So we're going to use some vec3s. V, I'm going to name that V. Oh, we're all good there. VT and VN. So that's so I'm just thinking of maybe I can combine these together in a way. Yeah, I can do something like I can combine the indices for these three things that are used liberally here, like that. I can keep track of if I use that one, which is also used directly above. Many of them are only used in one place, which is concerning, but not really. So I can keep track of each of these, and if I use the same one again, I can just use the same vertex again. Some of them are used in a whole bunch of places. Well, I found one that was used in 3 places. What? Oh, that one's not used. That one's used there and there. I mean, there's what, 4,300, well, less than 4,400 lines with 3 per line. 4400 times 3 is 13200. If I store int to int map with 13,000 entries, that's not a big deal. Yeah, let's just see what happens. Okay, like we're going to use the best ever feature of C++, F streams. Everybody loves them. Nobody secretly looks at Stack Overflow on their other monitor whilst decoding them. Whoa, let's choose the right variable name. Let's load the input file string, and then we need a line. Now we call this getLine function. Is there a better way of doing this? Probably a better, like a C++ 17 way of doing this. Okay, so we get a line. The lines always start with a single, or not a single letter, but like a command sort of thing. So let's have a look at the command. It's in line, so we can get an iString stream. No, I keep typing in name for everything. Oh, it's line. Is iString stream? Okay, so we got one of them. This is, I bet if you did this with like printf or whatever it is, it would be a lot faster. So this could definitely be better. That's nice. Okay, let's check out what the command is. B, not V. The keys are right next to each other. So we're defining a vertex. Just to confirm a vertex is just 3 floating point numbers, one after the other. So it's pretty easy. We just need a vec3. Let's call it pause. And then we want to pause Z. And we want to just ooh. One other thing is that all of this stuff is indexed from 1. So maybe I could just subtract a bunch of stuff from the indices. It'll be fine. If it's a texture, we only need vec2 this time. It's like a UV coordinate. So get those out just to double check. VT is indeed just 2 floating point numbers. And these go into VT. So as you can see, I'm simply mirroring the structure of the file in code. It's a normal, that's fine too. I mean, if there were a lot of these, I would make this a little bit less. It's kind of the same piece of code 3 times. Disgusting. In fact, this is all very, very inefficient, but it's a good file format if it's that easy to read. Oh god. I got some notes here. Huh. My notes seem to indicate that the F lines can have more than just a triangle. Seems strange. Why is it written like that? So F is a face. I'm looking at the actual spec. Oh, it's not the spec, but it's someone's description of it. Face. Oh, I can do a bunch of stuff. Curves and surfaces. Search for face, but it says surface all over the place. Yeah, okay, there's a whole bunch of stuff. I mean, I should probably just look at asimp or something. Oh, you build it via CMake. That doesn't make me happy. See, this is probably what I should be using. But seeing as I'm currently only loading a picnic table, well, yeah, I definitely need to learn something better than this, because there's a whole bunch of stuff in an obj file that could really screw it up. Okay, so yeah, here we've got 1, 2, 3, 4. I mean, it's invalid, but it does exist. Well, it's not invalid because of the 4, I mean. So presumably if there's lots of them... Is there any in this file? This is the only one I'm really loading. It doesn't seem like it. The only other file I had was the mirror. And this is back from my old test project. Oh, that does have multiple ones. Oh, okay. That's why my notes have a really weird structure. It's all clear, almost like I should have figured this out more recently so that I'm not going by some old nonsense. Okay, so you got a face. It's gonna have some X, Y, Z stuff, which determines some vertices, texture coordinates, and normals. But we want to make each of those into an actual little vertex, and we want to store the index somewhere. So I could just map from little string, standard string, to index. which is nasty. I don't really want to do that. I don't want to populate this with a million strings. Well, again, this is a really garbage piece of code, so I shouldn't be so precocious about the quality of it. I'm probably going to learn how to use ASIMP, which is a hilariously named asset importer. That's an open source, I believe, project, and I've heard that it's pretty good. And there's no point writing this stuff when you could learn it, but seeing as I'm here now, I'll keep going. I don't think I'll bother doing ones that support multiple triangles and faces. Oh, in fact, if I'm making it really bad, I don't actually need to. I don't need to make any of this good. This could really be just the worst garbage. Really could be the worst garbage. So let's make it the worst garbage. So we get a group that's like X, Y, Z. And that's inside ISS, so there we go. Let's just literally duplicate all the vertices as many times as we need. It'll all come out in the wash when I can actually import models sensibly, using a tool that's specifically written to interpret a bunch of different file formats. Almost like that's how you actually do it in the real world. Oh, okay, so we got this XYZ thing. I'm pretty tired, but I want to just keep pushing onwards because that's how you become victorious. Let me use the index type. Okay, well, wait, I don't know why I put that there. So what I'm trying to just get my head around a little bit. We have an index for the vertex and the texture and the normal index. So these are the indices. Then we need to break that actual group apart. I can't name it ISS because that's going to shadow, so I'll name it GSS for group string stream. That's going to act on that little group. It's also got a separator character, so then I just want to do GSS VI separator VTI separator. And I'm totally taking advantage of the fact that these are always specified, even though the spec we just looked at indicated that that was not necessarily true. Once again, a proper library will handle this better. For now, I'm forging onwards because I want to get the rendering structured rather than like this whole function will be replaced with the Cultural library. That's my dream, and I'm just trying to convince myself that that dream is worth following. Oh, okay. So then we can say v I well -1 m mesh add vertex static. Oh well. What do our vertices look like? I forget. Oh, pause UV in the shade. I don't even care about the normal. I probably should though. Shade. This is going to be 0.5. Okay. So we add a vertex. Oh, I see how to do. I see how to do this. Yes. Aha! Then M mesh add triangle I0, I1, I2. Ha! Possibly imported, probably will crash. Love it. This is such nonsense. Isn't it good? No. But regardless of whether it's good or not, I need a class to hold a model, and I need to be able to get a pointer to its mesh. And I need to set the bucket state on it, I guess. Let's just see. Out of interest, did I ever wire up this load asset function? I did. Look at that. It does actually load an asset. So let's go to rendering engine and define the map, I guess. From int to, let's make it more unique pointers, I guess. Model. So, oh no, loading an asset is really useless because it doesn't record the file name. So it says, hey, load this file name, and it's going to load it up and then say, hey, this file name is now this ID or whatever. So whatever. It's going to be a map from string to models. Who cares? This is actually only called from one place. So it's just, we know that it's only going to be here. Oh, this is a big hack. That's actually a unique pointer. Oh gosh, this is definitely going to need. Well, control ends there. Okay, you can return 1. Who cares? Wow. Let's see if it works. Or works is a bit of a. I mean, nothing happened, but is that because computers are disgustingly fast? Let's just put a breakpoint towards the end of this function and see if it actually breaks on it. It does. And there's 0 items in all of these values. Is that just because it's the end of the function? Or what did I actually call this with in the script? It's models. That's not what. Where is it? It's trying to open the wrong file. It's just in the data directory. Data. There we go. So stopping this debug. Let's see what happens when you actually run it with maybe the right file name. Well, it still just didn't do anything. Let's try debugging that. Bish bash bosh. Wow, it loaded up 1,380 vertices. Yep, there's a lot of them. They seem totally wrong. I mean, also, I feel like there should be more. Well, maybe not. So what was the first one? 0.41, 0.82, 0.85. So what we got here? 236. No. 23 quadrillion. Now, I'm not a number expert, but I think 23 quadrillion is different from the stated value, 0.41. You might think they're the same number, they're actually not. Let's try debugging from the start. Okay, so we got some arrays, open the file, we'll get a line, the line is a thing, so I don't care about the line. This one's also a current, don't care about it. That's a command that I didn't care about. My perpetual inability to care about the quality of this is probably the reason why it doesn't work. Okay, so there we got a little vector. So that should go there, and that should pop in that one. Oh, it actually gets the right values. And it pushes them back on V. Oh, is it just because it went out of bound or out of scope or whatever? Is all this stuff a little bit academic? 3,800. Oh, it actually looks. It looks correct. Interesting. I think it genuinely loaded some stuff. Good griefy gumdrops. Yeah, I don't actually care about this code so much. This is all just like stopgap measures to make something that does a thing. Okay. And then I need to adapt render room. So there's a texture, uniforms program, vertex array. They'll need to go, which is a bit convoluted for just now. But what I can do, oh, I already made this a mesh of vertices called vertex. What I could also do is make that instead of a temporary there, make it into an actual thing. A little function to clear out the mesh. I said M mesh or clear, but this mesh is definitely not. Fill in bash, bosh. So this is really M mesh. This actually a reasonable use of it. I know I could have done the global copy paste, but I don't want to do a global copy paste. And this isn't particularly slow. These vertex, yeah, just add the type of vertex that it really is. You know in your heart of hearts where it should be. Okay. So the important thing here is it does indeed build a mesh, what I call a prepare function. So, this is almost like a thing that's gonna do something. Not something sensible. Oh god, I'm so sleeperific. It is very late for me. I'm very tempted to end the stream, even though it's somewhat of an arbitrary point, because I'm losing the ability to concentrate. But then again, when you're super tired, that can be when the genius comes out. The one who connects all the bits together like it makes sense, and then in the morning you're like, how? What? But maybe it works. Well, I wouldn't count on it. Anyway, I'm just a very tired person. I'm not gaining any secret enlightenment. So this instantiates a bunch of render rooms, which is silly because it shouldn't be doing that there, but it does because the constructor does a bunch of silly stuff. That's fine. Well, it's not fine, but it's whatever it is. Then it calls prepare on all of the rendery rooms, which makes sure that they are not dirty and builds meshes and stuff. That's cool. But I'm just going to keep adding stuff in because I have no idea. Let's just see if I can fill all of the rooms into one bucket thing. Okay, so I can get the mesh for each thing. Okay, so they're all prepared now. Let's just do this once. Fill with a vector of mesh pointers. bunch of pointers. I'm just minging through the code right now. For each one, add the mesh, and now fill those meshes in. Is that gonna just cause fear and hatred? Flow. That's got no I. There we go. Yes. I've got a bunch of template problems. So dependent name mesh vertex D is parsed as a non-type, but instantiation yields a type. Cool. It's, I think, a type. Because it doesn't know ahead of time what that really means. Okay, narrowing conversion of index count from size T. Of interest. Do I still have that docs.gl open? I believe I do. Nope, I hella don't. Let's just go GL draw element space vertex. Just quickly check, what is this expecting? Size and int. So that could be a size. Let's just deal with it in the most basic way possible. Okay, let's see what happens when we try and put everything in one big old vertex buffer. Didn't do anything. I'm getting suspicious. I want things to just horrendously crash a bit more. It's unnerving to have stuff that does things and then is happy. You know, I want some real nasty crashes happening. Okay, that model loader kind of worked, apparently. Oh, here's the fill. What's it going to do? It's going to count up 8 rooms worth of vertexes and indexes. Whoa, it's like 250,000. That's really way too many. Why is the indexes? Ah, whatever. $28,944. Of course, they're all exactly the same. Well, that seems nice. Possibly even correct. There is a way to make the room meshes a lot simpler. Obviously, an empty room having, you know, 19,000 vertices and 28,000 indexes isn't indices. It's not great. Especially since there's anything pretty similar, like if you put anything in the room, that number will probably stay about the same. I've done 1 hour 20, that's usually about how far I go. I really need to get my head around how the thing that instantiates the drawing will be. So I want something that has the program. The program should exist once, as well as a thing that's got just a big old dictionary of textures or something like that. And then we can make the bucket the thing that's got the program will say, hey, here's your big bucket of data, bind your vertex array into that. And then the rooms and the models will know to call to this thing and say, hey, start the right program and render this bucket state with these textures bound or whatnot, you know, the usual. And then it can just do it. So I think I just described what I need to make. But at this stage, I'm starting to feel real terrible, so I think I'm going to, once again, try and end the stream on 1 hour, 23 minutes and 45 seconds. If you've been watching along, thanks very much. I hope you enjoyed it. If you're watching later, then same. If you're watching it earlier, then how? I got further than I expected. I'm going to look into ASIMP tomorrow. ASIMP. Asset Importer. Open Asset Import Library. Short name ASIMP. Sounds so bad. Oh. Or maybe ASIMP is not what I should be using. But I feel like it's... I think it's the right thing. Oh, I hope it's not huge. I wanted to be able to load an obj file and combine the vertices together. So that's what I'll probably do tomorrow. Other than that, I think it's time for me to head to bed and catch some Z's. And the quest to make weirdly batched rendering will continue until I get sick of it and decide to try and write a physics engine, which will be about as hilarious as this mess. it'll all be fine in the end. Iron out enough wrinkles and anything can become smooth. I don't know. Alright. Thanks very much. Goodbye.